give this integral attempt. So I'm going to go through my solution now. So the solution that I'm going to use entails partial fractions. Okay, so what we're saying is this 3x squared minus x over x minus 1 into x squared plus 1 can be expressed as two different fractions, as the sum of two different fractions. So what are these fractions? That's what partial fractions is all about. We're trying to find them. So we have x minus 1 and some constant a over x minus 1 plus bx plus c over x squared plus 1. Now the reason why we have bx plus c is because x squared plus 1 is an irreducible quadratic. So what that means is that we can't reduce x squared plus 1 into linear factors. Okay. So now if I multiply every term in this equation by our denominator on the left-hand side, then we will just be left with 3x squared minus x on the left. And then on the right, the x minus 1s will cancel when I multiply this term by x minus 1 into x squared plus 1. And I'll have a into x squared plus 1. And then when I multiply in the denominator into this term, our x squareds plus 1s will cancel. And we'll be left with bx plus c multiplied by x minus 1. Okay, so the next step is to simplify this right-hand side. So let's go ahead and do that. So distributing this a, we get ax squared plus a, and then using FOIL to distribute these two factors into each other, we get bx squared minus bx plus cx minus c. Okay. So now we're going to group terms. So we're going to group all the x squareds, we're going to group all the constants, and we're going to group the terms with x to the first degree. So doing that, we get a plus b into x squared. We took our x squared out as a common factor of those two terms. Then we have c minus b into x, taking out our x as a common factor of those two terms, and then plus a minus c. Now it's useful to write over here plus 0, because that's what our constant is on the left-hand side. So now we can equate coefficients. So we have a plus b is equal to 3. We also have c minus b is equal to negative 1. They're both the coefficient of x. And then we have 0 is equal to a minus c. Okay, so if 0 is equal to a minus c, then a must equal to c. Okay, so if a is equal to c, then I can write this as a minus b being equal to negative 1. So if I do that, I have a minus b equals negative 1 over here. And then if I subtract those two, then my a's will disappear, because a minus a is 0. Then we'll have positive b plus b, which will be 2b, and then we'll have 3 plus 1, because this negative times by negative 1 is positive 1. So it's 3 plus 1, which is 4. So therefore, our b must equal to 2. And if b is equal to 2, then it's clear to see that c must then equal to 1. And if c is equal to a, then a is obviously also equal to 1. All right. So now we can express this term. Instead of using these a's and b's, we can get rid of that a, and we can put 1. We can get rid of this b, and we can put 2. And we can get rid of this c, and we can put 1. All right. So now, instead of solving for the integral of the left-hand side, we can solve for the integral of the right-hand side. Okay, so our integral is now equal to 1 over x minus 1 plus 2x plus 1 over x squared plus 1, and that's dx. Okay, but now we can split that into two different fractions, so we can have plus 1 over x squared plus 1, and then of course what we can do is we can split all of these integrals up as such. Okay, and we can solve for these integrals individually. So for this integral here, we're going to make a u substitution. So we let u equal to x squared plus 1. So therefore the derivative of u in terms of x must equal to 2x. Okay, so if we make that substitution, we will have the integral of 1 over u, because our denominator we're substituting in for u, and then for 2x dx, we're substituting in du. Okay, and then solving this integral, it's simply the natural log of the absolute value of x minus 1. And then solving this integral, we know that to be arctan of x, then of course plus c. Okay, so continuing, we have the natural log of x minus 1 plus, and then that integral solved is the natural log of the absolute value of u, and that's plus arctan of x plus c. But now, we originally said that u was equal to x squared plus 1, so we can instead then write x squared plus 1. But x squared plus 1 is always positive, so we don't actually need this absolute. We can have normal brackets there. And that is the integral solved. I hope you're able to solve it, and of course, if you were, well done. And I'll see you tomorrow for day 87 of the countdown. Thank you.